Today our topic is friction. What is friction? In statics, we define friction as resistance to motion. That means whatever will resist in my motion, we call it friction. And it is always opposite to the motion. That means if my motion is this way, resistance will be this way. If my motion is this way, resistance will be that way. So that is always opposite to the motion. Third is heavier the object. If my object is heavier, the friction will be larger. And then the surface. If the surface roughness increases, my friction will increase. So if I draw a, so there is a body here, I want to, and my surface is here. If I want to move the body this way, if I want to pull, if I apply force this way, then the body will tend to move that way. My friction will be this way. So this is F force, friction, frictional force. So if I apply force that way, that means my body is intending to move that way. My frictional force will be this way. If I apply force, say this way, and not this one, then what will happen? My body will try to move this way. In that case, my friction will be this way. So it is always opposite to the motion. That is this statement. Heavier the object, that means whatever my friction force in this case, if I add more load, then my friction will be higher. It is common sense. If you want to pull something light, it's very easy. But if you want to pull something heavier, it is difficult because as it is heavy, the friction is also larger. Okay, then the surface. If this surface is very rough, then there will be huge amount of friction force. So that is another concept. So frictional force, it depends on, say, okay, so this is my category. So frictional force depends on the weight, the weight and the surface roughness. So what about the force on this? If my reaction force, so whatever I will apply on the surface will apply the same thing. So we call this R. R means the reaction, the surface reaction, normal to the surface. That is whatever the angle is 90 degree. So that is called R. Then my frictional force will be mu times R. Mu times R. What is mu? Mu like takes care of this roughness. We call it coefficient of friction. Now, if the body is in static position, if the body doesn't move, but it wants to move, it tends to move, then we call it statics. So, that means S, mu S. So, coefficient of static friction. If my body moves, then we write this way. My frictional force will be mu Kr. Is called kinetic or coefficient of kinetic friction. So K means kinetic. So this one is coefficient of static friction. Coefficient of static friction. Coefficient of static friction, coefficient of kinetic friction. Now something to explain. So my body is at rest, I am pulling, some friction is generating, I am pulling, friction is increasing, and then after some times my body will starts moving. Once it starts moving, my frictional force uh, uh, will change from here to there. That means when my body is not moving, it is intending to move or it is trying to move, then my frictional force is this. Once it starts moving, then my frictional force will be this one. I need to use this one. So you need to be careful like which coefficient to use. If the body is in motion, then you have to use this one. If the body doesn't move, then it is this one. Now something else is like sometimes we get confused. Is this the friction value? Is this the amount of friction? It is not. It is the maximum amount of friction. That means if I do not pull, what is the frictional force here? Actually, no friction. If I start pulling, then if the body doesn't move, then summation of Fx is 0. Summation of force this way is 0. That means this force must be equal to this force. So if this force is 0, this force is 0. Okay. Okay, right, this way. So if my pull force is 0, my friction is also 0, because this must be satisfied. Summation of Fx is 0. Summation of force this way is 0. If I increase the force to 1, it will be 1. So 2. When I will exceed mu s r, when my applied force is this, then my frictional force will be this. If I increase something more than this, then my frictional force will be mu k r. That means now the body is in motion because my applied force is more than this. Maybe it is confusing to you. In next video I will make an example. In that case it will be clear. So for now, just make sure you understood this point. Friction is the resistance to motion. It is always opposite to the motion. That means okay, it is always opposite to the motion. If I want to expand this, say there is a surface here, inclined surface. My body is in here, my body. So if I want to hold the body in place, that means I am applying a force to hold in place. So I want to hold the body in place. Then which way the body is, like in what direction the body wants to move, this way or that way. In normal case, the body will be moving this way. I want to hold it like this. That means my frictional force will be this way. Oh no, sorry. As the body will move this way, my frictional force will be that way, the opposite, if I want to hold the body in place. Now the same thing. Okay, right here, this is my friction. Now same thing, say now I want to pull, or whatever is, you can apply this force or this force. Now I want to pull it up. So this will go up. I want to move the block up. Then what will happen? My frictional force will be this way. So this is something you have to like be careful. What is the direction of my friction? Whatever the direction of the motion, the friction is opposite. If I want to hold the block in place, that means the block wants to move this way, frictional force will be that way. If I want to take the block up, my frictional force will be down. That is something to remember. Okay, so I will stop here. In the next video I will solve an example. Thank you.